We are given a semicircle of a diameter x, which is to be cut from a rectangle with a length of 80 centimeter. They are asking us to determine the value of x, which gives the maximum shaded area, and then we shall give our answer in terms of pi there. So we know that this x, it is what? The diameter, and the diameter is made up of 2 pi. So in order to find the radius of our semicircle, which is just a line from the center to the circumference of the circle, we simply what? Half our diameter there. So the r and the 2 and the 2 rationalize, so the diameter is what? Is x all over 2, which is what? Half x. So now the radius is what? Is half x. So now, since you're dealing with a semicircle, you know that whenever you have a full circle like this, to find the area of a full circle, you'll say what? This is area into pi r squared. So you use this formula, area is pi r squared. So remember that a semicircle is what? Is just half of your circle like that. So it means now you have what? You have the r there. To find the area of a semicircle, you simply say area is what? Is pi r squared all over 2. Is what? Semicircle. The semicircle is just half of the cycle. So now you just have to make the substitution. So this is pi into what? The radius is 1 all over 2x and then squared all over 2 now. So now to find to solve this further, or to simplify this further, you have 1 all over 2 pi multiplied by 1 all over 4x squared. So now this is going to give you pi x squared all over 8. So therefore, this is the area of the semicircle. So now we have to find the area of a rectangle. The area of a rectangle is just the length times breadth. The length is what? Is 80. The breadth is what? Is x, which is the diameter of the semicircle. So this is going to give you what? 80x. So now we need to find the area of the shaded part. We're just going to say the area of the shaded part is just what? The total area of a rectangle, which is 80x, subtract the area of a semicircle. So now you have what? The area of the shaded part there. So now the question asked us to determine the value of x, which gives the maximum possible shaded area. So let's say you have a function like this. Whenever you have a function like this that curves down like that, we call this what? The maximum. Whenever it curves up, that's what? The minimum there. So we know that at the stationary point, the gradient is what? The gradient is 0. So at the stationary point, the gradient is 0. So the gradient is what? Remember, it is the slope. So the slope is 0 at the stationary point. So where we have what? Where we have the extrema or the maximum or the minimum there. So it means now we can take the first derivative so that we can get into what? Into the extrema or what? The maximum or the minimum or the stationary point. So you take the first derivative. So this is going to give you what? 80 and then minus what? Minus 2 pi all over 8x. So remember, I'm using the power rule. Né? So we have to equate this to 0, or we know that at the stationary point, the gradient is 0 there. So this is 80 minus what? This is going to give you pi all over 4x. So now to solve for x, you take this to your left. So you left pi all over 4x, which is equals to 80 there. So now divide both sides by pi all over 4. This is the same as multiplying by what? By 4 all over pi. So now the pi all over 4 will rationalize. So therefore, x is what? Let's see what is x. So this is 80 multiplied by 4. It is going to give us what? 320 there. So this is 320 all over pi there. So now this is what? The value of x at the stationary point there. So now, for us to prove if whether this is this x here, it is what is going to give us the maximum possible area. You simply what? You simply take the second derivative. When you take the second derivative here, so when you take the second derivative, this is your first derivative. When you take the second derivative here, you're going to have what? You'll see that this is going to disappear, and you'll have what? You'll have negative 2 pi all over 8. I told you before that whenever the second derivative is less than 0, this gives you what? The maximum. And whenever the second derivative is greater than 0, this gives you what? A minimum. So this is true that at x is equals to 320 all over pi, the shaded area is what is at maximum there. So this will be what your answer. So they were just looking for what? For the value of x, not the maximum value of x there. So now let's take a look at the next question. So now this question states that, let me zoom in. Okay, they say that we have a satellite to be constructed in the shape of a cylinder with a hemisphere at each end. The radius of a cylinder is r meters and its height is h meters. So now the outer surface area of a satellite is to be coated with heat resistant material, which is very expensive. The volume of a satellite has to be pi all over 6 centimeter cubed. So whenever you have cube, just know that this is what the volume. Yeah, this is the volume, and it is given here that the volume of a sphere, your sphere is what is this part here. This is what the sphere. So this is the sphere, and then this is what the cylinder. Cylinder. So now to find the volume of a cylinder, since they say that the volume of a satellite has to be, or the volume of a satellite has to be pi all over 6 cubic centimeter. What is the satellite? The satellite is the combination of what? Of your cylinder and what? And the sphere there. So now the first question says that we have to show that the height is what? Is 1 all over 6 r squared minus 4 r all over 3 there. So now this is what? You can see that your 1 all over 6, it is what? It is in this equation there. So it means now they are using what? The volume of the satellite. So we are just going to say, okay, the volume is just the combination of what? Of this volume of the sphere and the volume of what? Of the cylinder there. So we're just going to say, okay, this is 4 all over 3 pi r cubed plus pi r squared and then h there. You know the volume, which is what? The pi all over 6. So this is going to be 4 all over 3 pi r cubed plus pi r squared and then h like that. So now we have to show that h has to be something. So we have to make h the subject of the formula. So now this is what? This is pi all over 6. Take this to your left. Your left minus 4 all over 3 pi r cubed, which is equals to pi r squared h. To find h, simply divide both sides by pi r squared. So this will be pi all over 6. This is the same as okay, divide both sides simply. Let's first divide like this, minus 4 all over 3 pi r cubed. Oh, sorry. So I was out of space there. So and then divide by pi r squared. So now this is the same as what? To find the h there, this is the same as saying pi all over 6 multiplied by what? By 1 all over pi r squared. So now the pi and the pi will rationalize, and then minus 4 all over 3 pi into cubed. This is the same as what? This is the same as multiplying by 1 all over pi r squared. So now the pi and the pi rationalize there. From 3 remove 2, you'll be left with 1, so that part you don't have there. So now therefore the h is what? Is 1 all over 6 r squared minus 4 all over 3 into what? Into what is this? The radius there. So multiply by r there. So remember, this is what you rationalize this and this. So now when you multiply here, remember this was 3. From 3 we remove 2. So this 3 is where? Is at the numerator then, not this one. Eh? So now this is what? The h, the expression of h there. So now let's take a look at the next question. So now they say hence, meaning there is a connection between between 1 and what? And 2 there. So now they say hence show that the outer surface area of the satellite can be given as what? As this. So now we need to find what? The total surface area of what? Of the satellite there, which is we are given those formulas there. The outer surface area of a sphere, the curved surface of a area cylinder there. So now let's deal with this here. So now this is number 2. So we're just going to say, okay, the surface area is going to be what? The 4 pi r squared plus what? Plus 2 pi r and then h there. So now you left 4 pi r squared plus 2 pi r. Remember the h is what? The h is 1 all over 6r squared minus 4r all over 3. So I was out of space there. So now let's see. This is 4 pi r squared. Let's multiply. When you multiply this to that, you'll have plus what is this? Pi r into 246. This will give you 3 r squared. So the r, and then here you left with 1, and then this time is that will give you negative 8 pi r cubed all over 3. So now you have what? You have 4 pi r squared plus pi all over 3r minus 8 pi r cubed all over 3 there. So now we can write this in a standard form, or we can start with this part there, and then you'll say negative 8 pi r cubed. So let's see if they said something. They said that hence show that the outer surface area can be expressed as this. So now let's go there. Let's see what you have. You have this, and then you also have 3r. So it means now we have to combine these two terms there. So to combine those two terms, let me see if I didn't left anything out there. So this is 2 pi r, and then multiply by, what is this? The 4r out there. So let me see if I didn't left anything. Oh, I didn't left anything. So now this is not cubed. The nega is, this is squared. Because see, this r times r will give you r squared there. So it means now you can combine these two, since the order is what? Is 2 there. So now we can go and say, okay, you have what? You have 4 and then minus 8 all over 3. For us to combine these two, we have to have what? The common denominator, which is what? The 3 there. So you have 12 minus 8. This is going to give you what? This is going to give you 4 all over 3 there. So it means now this is what? This is 4 all over 3 pi r squared plus pi all over 3r. So therefore, this is what? The surface area. So let's see if we have the same thing. Yeah, if you check there, we have the same thing. So now let's take a look at this one. So now they say that we have to calculate the minimum outer surface area of the satellite. Remember, the minimum, this is the stationary point where the slope is what? Is 0. So we have to take the first derivative of this. So first, write down your formula, or the surface area formula, which is 4 pi r into r squared plus, let's take the reciprocal of this so that we can take the derivative of this. So this is 1 all over 3 pi and then r minus 1. So the reciprocal, remember, is the opposite of what you're seeing. You have the invisible one there. When you take the reciprocal, now you have what? A negative exponent. So take the first derivative of this. So the first derivative, I can say this is now a function of what? Of r there. So now this is 2 times 4. That's going to give you 8 pi all over 3 into r. I'm using the power rule. So now this is going to give you negative 1 all over 3 pi r minus 2. So now let's take this back. Remember, you have to equate this to 0. So this is 8 pi all over 3 and then r minus 1 all over 3 and then pi r squared. So I just took that back. So we can take the one which is negative to the left. So it means now you'll have what? 1 all over 3 pi r squared. So now this is equals to 8 pi all over 3 r there. So now we can do what? We can do the cross multiplication. This time is this 8 times 3. So this will give you like 24 into pi r cubed, which is equals to what? Which is equals to 3. So now this is 8 times 3. Yes, it is 24. So the 24 divided by not 24. So let's divide everything so that we can keep r as the r cubed as the subject of the formula. So this is 24 pi all over 24 pi. So the 24 and the 24 pi will rationalize, so you have r cubed, which is equals to what? Which is equals to 3 all over 24 pi. So now take the cubed root. Remember, you left plus or minus when you take the square root. So now the r the 3 and the cubed root there rationalize. So now therefore your r is what? Let's see. So the cubed root of 3 all over 24 pi. So this is 0.341. Okay, I'm just going to round it to decimal places. So this is 0.34, and this is going to be what? Centimeters. So let's see what the question asks. Calculate the minimum outer surface area. So now they were not looking for the what? The value of r. So we have to take this back into what? Into the surface formula, which is the original formula there. This one. It means now therefore the surface area, which is now a function of r. So let me first write this down. So this is 4 pi all over 3 r squared plus 1 all over 3 1 all over 3 pi then r. So now let's make the substitution. So it means now this is 0.34, which is equals to 4 pi all over 3 4 pi all over 3 into 0.34 plus 1 all over 3 pi into 0.34. So now let's see what we have there. So now this is going to be 4 all over 3 multiplied by pi into the answer, and then squared plus 1 all over 3, and then pi into the answer. So now this is 0.7, okay, 0.8. I'm just going to round it to decimal places, 0.8. Nah? So the answer here, it is 0.8. So now remember you have the squared there. So now this is 0.8. So you are done like that. So now let's move to the next question. Oh, where's this going? Sorry for that. So now let's say that a soft drink company has to design a can with a volume of 450 cubic centimeters. So now the volume is what? Is 450 cubic centimeter there. So the formula for the volume is of a can is given by that. So cubic centimeter, where r is the radius of the base and h is the height of the can. So now let's say in the first question there, determine h in terms of r. So now we're just going to start here where we have enough information. So the volume is what? Is 450, and we're told that the volume is what? Is pi r squared multiplied by h. So make h the subject of the formula, divide both sides by pi r squared. So the pi r squared will rationalize. So therefore the h is equals to what? 450 all over pi r squared. So now this is what in terms of r. So now this is determine the total surface area. Okay, the total surface area of a can is given by this. Show that the total surface area in terms of the radius is given by that. So now they are giving you what? They're giving you the formula here, and now they're telling you what? To prove that the surface area is indeed what? 2 pi r squared and then plus 900 all over r there. So now that's very simple. Just going to say, okay, since we're given the surface area formula, this is the surface area formula is 2 pi r squared plus 2 pi and then r multiplied by h. So remember that you have an expression of h here. So let's make the substitution. So this is 2 pi r squared plus 2 pi r. The h is what? Is 450 all over pi r squared. So now the area is what? Is going to be 2 pi r squared and then 454. 2 times 4, that's like 8. And then what is this? This is going to give you, let me see, 400 times 2, That's like 900, né? So this is 900. So 900 pi all over pi r squared. So this is going to give this one and this one rationalized at the bottom. So therefore, the surface is this the surface area formula is just going to be 2 pi r squared plus 900, and then you have what? Oh, the pi and the pi rationalize all over r there. So now this is the surface area formula, and we have shown that indeed that's what they were looking for. So now let's move to the next question. So now they say that we have to determine the radius for which the surface area will be a minimum. Remember, at the minimum, this is where you have what your stationary point, and the slope is what is 0 then. So now take your surface area formula, which is a. So now you can write this as what is a function of what, of a radius, or r, since r is your independent variable. So this is 2 pi r squared plus what, plus 900 all over r. So 900 all over r. So now let's first write this nice so that we can take the derivative directly, or we can use the basic derivatives rule. So take the reciprocal of this, just the opposite of what you're seeing. You have an invisible one there, so you'll have something like this. So take the derivative of the surface area. You'll have what? You'll have 4 pi r, and then minus 900 r minus 2. You have to equate this to 0, so you'll have 4 pi r minus 900 all over r squared. So take that back so that you can take this to your left. So you'll have what? You'll have 4 pi r all over 1. So cross multiply, you'll have what? You'll have 4 pi r cubed, which is equals to 900. Divide both sides by 4 pi. Divide both sides by 4 pi. So the 4 pi and the 4 pi will rationalize. So the r cubed is you have 900 all over 4 pi. So take the cubed root. So you have plus or minus, don't forget. So now this and this rationalize, so therefore r is what, is plus or minus. Let's see what's the answer then. So the cubed root of 900 all over 4 into pi, this is 4.15. 4.15 rounded to decimal places. So now we have to verify, guys. Yeah? You have to verify which one is the answer then. Remember, you have two possibilities there. So now let's verify. We're just going to start with what? With let me just divide here. So you have a table there. So now let's start with what? With r is equals to 4.15, a positive answer. So remember that at the stationary point here, now this is your stationary point, then your critical point. So it is 0. Remember, it is 0. When you plug this to your first derivative formula, you will have what? 0. This is the reason why we equate this to 0. So now let's test by substituting values that are less than 4.5 and greater than 4.5 to our first derivative formula. So let me first write this nice. So you have 4 into pi. Let's try 3 is less than 4, and then minus 900 all over what is this? The 3, and then this is squared. So the answer is negative. Let's try a number greater than 4.5, which is 5. So you have 5. So it is positive. So now it is negative and then positive. So it means now your function is what, is decreasing, and then there the gradient is what, is 0, and then like that it increases. So this is what the minimum. So the question was what? Let me go there. Determine the radius for which the surface area will be minimum. So therefore, r is what, is simply 4.15. You don't need to test the other one, since this gave you what, the minimum. So therefore, r is equals to what, is 4.15 centimeter, like that. So determine the radius for which the surface area will be minimum. So the radius is equals to 400, or the surface area will be minimum at what? At r is equals to 4.5. You can conclude like that, guys. So we are not done. Let's take a look at this one here. So now they say what the company wants you to use as little material as possible. You see, guys, the optimization is all about what minimizing the cost. Né? It's all about minimizing the cost while reducing what. Or it's all about minimizing the cost while increasing efficiency. So now the company wants you to use a little material as possible. We don't want to use so much material. Ne? So for designing the can depth, so they say that what should the height of the can be? Ne? What should the height of the can be? So you're just going to say, okay, your surface area formula is that one. Then, so where can I take this? Okay, let me just write it here. This is the last question. So we want to use as little material as possible. Ne? We don't want to use much. Ne? So now the formula is what is 2 pi. No, this is it the formula? Is it? Yeah, yes, it is the one. So this is 2 pi r squared plus 900 all over r. So remember, the question says what? The company wants you to use as little material as possible in designing the can. What should the height of the can be? So remember, we have an expression for the height there. So you don't have to go here, guys. That's why I have to read the question again. You don't have to write the that down or the surface formula down. So you have to say, okay, h is what is 450 all over what? All over pi r squared. So now let's make the substitution. This is 450 all over pi, and then what? Let's see. The radius is what is 4.15 and then squared. So now let's see what's that. So I have to show you here while we are punch up here, guys. While we punch our values there, so that you can know how to use the calculator. So now let's see. This is 8.34 rounded to the decimal places. 8.34, and then the height is just going to be centimeter. So therefore, HE is that. So now, guys, let me help you. Yeah? They say determine the radius for which the surface area will be a minimum. It's all about now we want to what minimize. Yeah? We don't want to what maximize. That's why they say that the company wants you to use the little material as possible. So remember, we minimized our surface area. We want to use little material as possible. So now the height has to be what 8.34 for us to use what little material is possible. So that's it there. So now let's take a look at this one. So I hope you can see. Let me zoom out like that. Okay. So now they say that a 314 milliliter can with height h centimeter and the radius r is shown below. So guys, this 340 milliliter can is what is the volume there. Remember, they say that 1 milliliter is equals to what 1 centimeter cube. So it means now this the volume now is what is 340 cubic centimeter. Since they say 1 milliliter is what is the same as 1 centimeter cube there. So now 9.16 that we have to determine the height of the can in terms of h. So remember, the volume of any shape is just what? It's just going to be what is this? The volume of any shape, guys. This is the area of the base multiplied by what? By the height. You see, in this case, we are not given in the formulas, guys. So the volume of any shape is just the area of a base. So if you have to check there, the area of a base is what? Is the cycle. So the area of a cycle, guys, is what? Is pi r squared. So this is pi r squared, and you have to multiply by what? By h. Why multiply by h then? Remember that if you have to check now, oh, not that, but if you have to check, this is what you have the area of the base and then multiply by height. Remember, the volume is what? Is length times breadth times what? Times height. This length and breadth are what? At the base, and then times what? The height. The base is what? Is the cycle pi r squared, and then multiply by h then. Understand? So this is how to derive the formulas. So the volume is what? Is 340 And then this is what? This is pi r squared times what? The h. Divide both sides by pi r squared, divided by pi r squared. So the volume, guys, is just the area of the base multiplied by height. So h is equals to what? 340 all over pi r squared. So now this is in terms of r there. So now calculate the length of the radius of a cone in centimeter if the surface area is to be what is to be a minimum. It means now we have to find the surface area of this cone, guys. So now to find the surface area of this cone, just going to say okay, S, or you can say A, doesn't matter. Né? So the surface area, guys, you just say okay, we have what here? We have there at the top. This is the top, and then what? The bottom. So at the top and the bottom, you have what? You have two cycles. So what's the area of a cycle? The area of a cycle is what? Is pi r squared. But how many are there? There are two. Né? So that's 2 pi r squared. Plus, now we need this what? This, remember, when you cut this thing, you have something like this. It looks something like this there. Né? So now what you have here is what? Is a rectangle. So that rectangle there is something, the shape is somehow like what? A cycle there, which is just what? The circumference or the perimeter. So if you wanted to paint this, guys, you'll start here and then at the back like that, like paint it in a cycle form. Né? So now that's what the circumference. What is the circumference of the cycle there? You can see that the shape now that is formed is what? Is a cycle. You have something like this. It's somehow like this, guys. 3-dimension. Né? So now you have something like that there. So what you have is what? Is the circumference, the perimeter, né? the layer of that thing there. So it is what? It is the cycle. So to find it there, the circumference of the cycle is what? Is 2 pi, and then you 2 pi r. You'll have to multiply what? By the h there. Why do you multiply by h? When you take it from the bottom going up, that's what? The height. So multiply by what? By h there. So now this is what? Let me write this nice. So this is 2 pi r multiplied by h. So now this is surface area is 2 pi r squared plus what? Plus 2 pi r. The h is what? Is 340 all over pi r squared. So now the surface area would be 2 pi r squared into what is this? 2 times, okay, 2 times 3, that's what? That's like 6. And then 2 times 4, that's like 8. That's 0 into pi r all over what? All over pi r squared. So the pi and the pi, the r and the 1 r at the bottom rationalize. So therefore the surface area would be what? 2 pi r squared plus 680 all over r. We are not done. You have to calculate the length of the radius of the cone if the surface area is what? Is to be a minimum. So now we have to what? Minimize. Né? You know that when we minimize, we simply take the first derivative and then equate to what? To 0 there. So now taking the first derivative of this, okay, before taking the derivative of this, you see you have the independent variable in the denominator there. So you have to take the reciprocal of that. It's just the opposite of what you're seeing. So it means now this is what? This is 2 pi r squared plus 680 r minus 1. So now the surface area is a function of what? Of r there. So taking the derivative of the surface area will be what? Be 4 pi r minus 680 r minus 2. And then we have to equate this to 0. So equating this to 0 is 4 pi r, not r squared, minus 680. Take this back so that you can solve. Why do we equate to 0? Remember, at the stationary point, the gradient is what? Is 0 there. So this is now your gradient. Yeah? We have to minimize this thing. So now let's find there what? The radius at the minimum or at the stationary point there. So take this to your left. You left 680 all over r squared, which is equal to 4 pi r. And then cross multiplication. This question is the same as the one we did here because I can see that they look the same. But you see, guys, doesn't matter now. It means now you benefit from this. This is r cubed, and then it's equals to what? 680 4 pi and then 4 pi. This rationalized, so therefore the r, just take the cubed root. Okay, let me just keep it, then take the cubed root, left plus or minus the cubed root of what, of 680 all over 4 and then pi. So let's see what's that. So the cubed root of 680 all over 4 pi, this is what, 3.78. so this is cos 2 plus or minus 3.78 centimeter cubed. So now we need to verify which one is the correct answer. Né? So remember, draw our small table there. This is 0. So let's start with r is equals to 3.78. And then substitute the values less than 3.78, greater than 3.78 to see how is this function behaving. Yeah? So we substitute to what? To the original function, not to the original function, but to your first derivative there, to your stationary point, or the function at the stationary point there, which is this part. So this is 4 multiplied by pi. Your r now is what, is 3. Okay, is answer, let me see, answer minus 680 all over the answer and then squared. So this is, oh ish, I said the values less than, what am I doing? Okay, less than that is just going to be 2. Less than that is 2. You see the answer is negative. Let's substitute greater than. Let's put 4. So 4. So the answer is positive there. So now it means you have what? You have negative and then positive. It means now the function is what? Is decreasing. And then 0 here, and then what? And then increase like that. Yeah? So it means you have a minimum at what? At this r is equals to 3.78. So now therefore r is what? Is 3.78 centimeter. Calculate the length of the radius of a cone if the surface area is a minimum. So you can conclude that when the surface area is at minimum, or the surface area is at minimum when r is what? Is 3.78. Yeah, make sure that you conclude that. Now let's take a look at the next question. So now this is let's see, guys, this is cost. Right? In optimization, make sure that you study. You have to know cost. You have to study those things that we did, minimizing and stuff. Né? So now this is cost. We have to deal with cost here. Let's say that a rectangular box is constructed in such a way that the length of the base, okay, let's make sure that we understand. The length of the base is 3 times what? Long its width. This is the width. So it means now the length is what? Is 3x. The material used to construct the top and bottom cost you what? 100 rand per square meter. Excuse. So now I'm just going to say cost for what? For top and the bottom. Just always write it like this. Now top and bottom, the cost for top and bottom is what? Is 100 per meter squared. Per meter squared. And then the material used to construct the sides. This is the side. You have how many sides? 1, 2, 3, 4. Remember, the front, the back, the side like that. So now the cost for what? For the sides. So I can just say sides. So just going to be what? This is 50 rand per square meter. So now this is the box. Have a volume of what? Of 900 or 9 meter cubed there. So now it means the volume is what? Remember, the volume of any shape is what? Is the area of the base, which is length times that. So length times breadth or width, and then times what? The height. So now let's say now determine an expression of the height of the box in terms of what? Of h. You're given what? You're given the volume, which is 9. The length is what? Is 3. X times what? That x. The height is just the height. So now this is what? Let's first deal with this. You have 3x squared and then h. So now determine an expression of the height. So you have to have he as what, as the subject of the formula. So this is 9 divided by 3 squared. So you'll have something like this. So this is an expression of what, of the height there. So now the next question, show that the cost to construct the bottom, the box can be expressed as that. So guys, follow these steps. Now this is how you deal with the cost. So now let me see which one I can use. Let me just use this. I think is navy blue, something like that. So now guys, to calculate the cost, this is very simple. You're just going to say what you're just going to say. Let's find what the surface area of or the area of the top part. And remember, let me just draw it like this so that you can see what you have. So you have 3 dimensions. So you have to find the top and the bottom. Né? The area of what? Of the top and the bottom. So now, first let's find the surface area of that. So now, the area, remember this is also 3x and this is x. Né? So now the area of the top will be what? Will be 3 into what? Into x, and then times x. You have to multiply this by 2, so you also have the same thing at the bottom, plus the area of what? Of the sides. The sides is these ones, 1 2 3. You have this and also have this at the back. Okay, let me make sure that you see what I'm painting there. You also have that at the back, and you also have this at the front, and you also have this there, the sides. Né? So it means you're just going to say what? You're now going to say, okay, the side is what? You have x and h there. So it means now this is what? X times h. That's how we calculate the area. But how many of those? There are 2. Then this part and this part, they look the same. So now let's calculate this part and the at the back there, the front and at the back. Yeah. So now the area of this the faces there is going to be what? Is going to be this times what? The height. Length times what? The height is there. So which is going to give you, let's see, the length times the height. So that's going to be 3x HA, and then multiply this by what? By 2 then. So let's make sure that we wrote this correct. The surface area of the top, this is 3x, and then what? The h, the x is there. And then this part, you'll take this and what? The height. Ne? And then this part, you take this and the height. There are 2 of those. And then this part, will take this, what? This and the height. So it is correct. So now you have what? You have 3x squared plus 2x HE plus what is this? 6x HE there. So when you sum the like terms, you have surface area to be what? 3x squared, and then plus what? Plus 8x H. So now to calculate the cost, this is the formula to calculate the cost. So the cost, or let me say the total cost is the same. You say, excuse, you say what? Excuse guys. Yo, okay. The total cost, you say what? You say cost. What is that? You're given the price. Let's say that this is the cost per square meter. Né? You say this cost per square. Okay, let me just say per square meter like that. Multiply by what? By the surface area. Né? Surface area. Surface area. So this is how we calculate the cost. You can name it C. So the cost per square meter. Remember that this 3x squared is what? Is for the top and the bottom. Né? So this is 3x squared. Okay, let me just keep it like this. What is the cost for the top and the bottom? The cost for the top and bottom is what? Is this part, which is what? The 100 per square meter there. So it means you have what? You have 100 multiplied by what? By 3x squared, and then plus what? Plus the cost for the sides. Here's the sides, which is 50 rand. So this is 50, and then multiplied by what? By the surface area of that, which is what? The 8x, and then to that. So now let's see what you'll have there. So now this is going to give you what is this? This is going to give you 100 times 3. That's going to give you like this is like 300, 300, and then squared, and then plus 50. Let's see, 50 times 8 there. So 50 multiplied by 8, this is like 400 xh. But remember, we have an expression for h now. So since we have an expression for h, let me say 300 x squared plus this part. Let's go back there. So this is 9 all over 3x squared. So 400 x all over 9 all over 3x squared. So now let me see what's that. So times 9 divided by 3, that's like 1.2 there. So this is 300. I know I have to fix here, something's wrong there. So now this is 1.22 all over x, and this x and the x there will rationalize. So this part has to match with this part. Let's see what's wrong. You see, 3 times 2 is 6, né? 3 times 2 is 6, so 6. And then you have what? 6 here, which is going to give you 600. Sorry for that, guys. So this is exactly what you have there. So this is 600x squared. And this is what the total cost. So I can say that, therefore, C, the total cost is in terms of x. Now let me say x. So let's start with that one there, since we see that what they're asking us to show that this what is this? It is written, they started with this part and then followed by 600, not all over. What am I writing? Or x into that. So now this is the cost. And let's go back there. You see? So you have to write it exactly how it appears there. So the pattern. Yeah? So now, guys, the next question. This is 3. Calculate the width of the box, that is the value of x. Yeah? If the cost is to be a minimum. You know that at the stationary point, that's where you have what? The minimum, the maximum. Where the first derivative is what? Is 0, where the slope is 0. So now we have to take the derivative of what? Of the cost there. So now, guys, let's first write this nice, né? So now the cost is what? Is the function of x. So for us to take the derivative of this, let's first take the reciprocal of that, so that we can use the basic derivatives rule that we are familiar with, né? Not the ones that I will introduce here. So I want to stick to your curriculum, or to stick to the grade 12 level. So now, to take the derivative of this, I'm just going to take the derivative of a cost with respect to x. Your x is your independent variable. This is going to give you 1.2 negative that to x negative 2. This is going to give you, let me see, 600. I think the same answer as that one there. So this is 1 point that. This is the same as the answer that we got there. So x into, okay, just x there. So now we have to equate this to 0 now. So negative, let's take this back. So this is x squared plus 122x. Take this to your left. So you left something like this, which is equals to this x. So cross multiplication, you left something like 1.2 x cubed, which is equals to, you have x, is it? Oh, you don't have the x there. So this is into 1.2 divided by 1.2. 1.200 there. So this and this rationalize. So I have to take the cubed root. So x cubed is this and this rationalize. You give left with 1 there. So the cubed root and the cubed root. This is plus or minus. This rationalize. So x is what? The cube root of 1 is just 1. So this is plus or minus negative 1. So now, guys, which one is correct? You always know that when you say minimum, you always have what? A positive answer. So this is true that x, I cannot prove, guys. You know that I did here. Né? We always get something like this, and the answer appears to be what? The positive value there. So you can prove it. You know how we prove it, né? And you can just take the second derivative of this. The second derivative of this is just going to be, remember, when the second derivative is less than 0, that's the maximum. And when the second derivative is greater than 0, that's what? A minimum. Yeah? So you can try, guys, but I know that x has to be what? A positive 1. And then has to be what? A centimeter. So now let's go back to the question and make sure that we answered what they were looking for. Calculate the width of the box. The value, or that is the value of x. The cost is 2. Okay. Calculate the width of the box. Remember, the width is what? This is the length, the width. The width is just what? The x. So if they said that the length, it means you have to say 3 multiplied by the value that we got there. You understand? But we are done. That's the answer. So let me see if the units have to be centimeter or meters, not centimeter. No? So this is meter. So the unit is just meters there. So that's it. So now let's take a look at this one. Okay. So now they say that we have a necklace. Okay, a necklace is made by 10 wooden spheres plus what? Plus 10 wooden cylinders. The radii of the sphere and the cylinder are exactly the same. Okay. The height of each cylinder is what? Is h. The wooden sphere and the cylinder are to be painted. Ignore the holes in the sphere and the cylinder. Yeah, this is very important there. Because otherwise, we'll not be able to solve this. Ne? So it will take time. If the volume of the cylinder is 6 centimeter, write down h in terms of r. If the volume of what? Of the cylinder, remember, this is what this is the sphere. And then the cylinder is something like this. This is what the cylinder there. So this is a cylinder. So we know that we have that height h, and you have the radius there r. So now they say if the volume of a cylinder is what is 6 centimeter cube, right? H in terms of r. So now remember that the volume of any type of a shape, guys, is this is the area of the base. If you have to check this cylinder, the area of the base is what? Is the cycle. So what is the area of the cycle? Is what? Is pi r squared. And then you have to multiply by what? By the h there. So now the volume is given by what? By 6, which is equals to pi r squared. And it is given here. You see? It is given there. But they don't tell you which one is the correct formula. So make sure that you know this by heart. Don't cram, né? So now divide both sides by pi r squared. So the pi r squared rationalize, excuse. So for that, so this is 6 all over pi r squared. So this is what in terms of r there, the height in terms of r. So now show that the total surface area of all painted surface of a necklace is what? Remember, this necklace is made up of what? Of a sphere. What is that? The sphere plus what? Plus the cylinder. Cylinder. Yeah? It's made up of a cylinder plus a sphere there. So now you're given this formula. This formula, guys, you have to know which what formula is this. This formula here is what? The formula of a cylinder. I told you how to find, or I taught you how to find it, that formula. You say, okay, this is the cylinder. Remember, this is what? This is the cylinder. The cylinder. Let me show you again. This is the cylinder. Né? You say what? You find the area of what? Of the top and bottom. And if you were to take a look at those things there, you have what? The two cycles at the top and what? At the bottom. So it means the area of a cycle is what? Is pi r squared. But how many are those two cycles, or how many are the cycles? If you have to check there are 2 of them. Né? So multiply by 2. So the area there of those 2 cycles, 2 pi r squared. And then plus what? Plus the layer. The layer is just the surface of what? It's just the circumference of what? The cycle, which is just 2 pi r. And then you have to multiply by what? By r. I told you why you have to multiply by r, because you're taking it from the bottom to what? To the top, so that you can have what? The height. So which is what? The h there. So you see we got the formula. And now this is the formula of what? Let me write it here. This is the cylinder. the formula for the what is this, the sphere, guys. Whenever you have a sphere and then slice it for two times, you'll form this. So what is the area of a circle? The area of a circle is pi r squared. How many of those slices there? There are many. There are 4. So you see, that's how we find it there, the surface area of a sphere there. So now you have to say the total surface area. This is going to be what, the surface area of a cylinder plus what, the surface area of what, of a sphere. So it means we are just going to say, okay, the total surface area is going to be what, this formula is remember, this sphere, the sphere and the cylinder, they are made up of what, of 10 wooden what, wooden spheres and wooden cylinders, né? 10 wooden sphere and then 10 wooden cylinders there. So you have to multiply by that 10. You multiply the whole thing there. So 2 pi r squared plus what, plus 2 pi r into h, and then plus what, the surface area of what, of your sphere, and then 10 woodens multiply there, you'll have 4 pi into that. So now let's make the substitution. 2 pi r squared plus 2 pi r. The h is what, is 6 all over pi r squared plus what, plus 10. Okay, this is going to give you 40. This one, this is going to give you 40 pi r. So now, hey, I forgot the r squared. You see, I forgot the r squared there. So now let's solve this before we distribute the 10 inside. You'll have 2 pi r squared. So the pi rationalize the r and the 1 r there. So it means 2 times 6, that's 12. So 12 all over r plus 40 plus pi r squared. 4 times 10, that's like, 10 times 2, that's like 20 pi r squared. And that, let me see, 12 times 10, that's like 120. So I have a positive remember, so 120 all over r plus 40. I don't know why I added that. So this is 40. So 40 pi r there. So 40 pi r. So now, if you have to check here, you have what? You have like terms, né? So the pi r squared and the pi r squared, they're like terms. So you can what? You can sum them. So this is going to give you 60 pi r squared plus 120 all over r. So therefore, this is the total surface area in terms of what? Of air. So now this is the function of what? Of r. So if you have to check what you have there, this is exactly what we got. So now moving to the next question, determine the value of r that so that the least amount is painted. So it's like minimum. You have to minimize now. Minimize. Okay, minimize. Minimize. We have to minimize. Né? We have to minimize this surface area now, guys. Let me erase that. So we have to minimize it. Let me just write it here, out of space there. So now, first, I'm just going to write down the formula, surface area. Okay, let me just say surface area in terms of what? Of r, since it's a function of r now. So I'm just going to write this in such a way that I can take the derivative. Né? So if you have to take a look at this one here, your r is what is your independent variable. So take the reciprocal of that is 120 r minus 1. So now the derivative of the surface area with respect to r, this is going to be 120 pi r, I'm using the power rule, minus 120 r minus 2, equate this to 0. You know that at the stationary point the gradient is 0. So this is 120 pi r minus 120. Take it back. Take this to your left. You have 120 all over r squared. This is 120 pi r divided by side. Okay, cross multiplication. This is going to give you 120 pi r cubed, which is equal to 120 divided by side by 120 pi, 120 pi. So the 120 pi will rationalize. So therefore, r cubed will be what? Be 1 all over pi. Take the cubed root. Left plus or minus. So this is rationalized. So therefore, r is what? So now let me see the cubed root of 1 over pi. This is 0.68 rounded to two decimal places. Now 0.28. Let me check something here. Let me confirm something. Okay, let me see. I thought that there was a pi here. No, I didn't make any mistake. No, let me check. Okay, yeah. I thought I made an error somewhere. Yeah. So this is what we have. Let's check the units. No. So the units has to be, it is specify now, or centimeter. So this has to be what? Centimeter, not cubed, but just centimeter. So that's 0.68 centimeter. So let's go back again. Determine the value of I for R of R so that the least amount of paint will be used. Remember, guys, you have plus or minus. Let's confirm now. But we know R will be a positive value, no? So I'm just going to do it with you. Just do it, guys. Ne? Confirm. I know that R is to be a positive value. Ne? So, but you can confirm if R is just a negative value or what. So now let's move to this one. I'm leaving that for you guys. Confirm, ne? Please confirm. So by now you know what's happening. So now they say that a box is made from a rectangular piece of cardboard, 100 centimeter by 40 centimeter, by cutting out the shaded areas. Ne? So we're cutting out the shaded areas along the dotted lines as shown in the diagram. Express the length, this length, okay, in terms of h. Okay, the length in terms of h depth. So remember, guys, that we are dealing with what? They said this is a rectangular piece. Rectangular. Okay, a box is made up from a rectangular piece of cardboard. Now this is a box. Now we are making what? A rectangular thing there, or shape like that. So now to express the length of I in terms of h, you can say, okay, remember that this part here, this part has to be the same as what? This part there. Understand? H has to be the same there. So what you're going to do is to say that the L plus what? The HE plus what? The HE has to be what? 40 there. So now it means the L is what? Plus these two will give you to HE is equals to 40. So now we have to make L the subject of the formula. So L is simply what? 40 minus 2H. So express L in terms of H there. So this is in terms of H. And this is source number one. So now let's take a look at the next question. Hence prove that, okay, when they say hence, it means there is a connection between the last question and the next question. So prove that the volume of the box is given by that. So the volume of any shape, you remember, guys, is the area of a base times what? The height. Right? So the volume is just the length times breadth times what? The height. So the volume is going to be what? The length. You can take this one is what? The 100. Is what? The 100 there. So, but if you have to check, you have HE, B, HE there. So now we can say, let's see the HE. You have something like this. You have 2 HE. The length is 2 HE plus what? 2 B there. But let me just write it somewhere. I know that the 100 has to be equals to what? The 2 B's, and then what? Plus the 2 H's there. The 2 B's plus the 2 H's. And then this one, this 40 is what is going to be your, okay, let me just call this the length. And then this my height. As I see, I won't have, what is this? What is this? The length, oh, the HE. I'm just going to keep the HE, guys. So the length, guys, is going to be what? The length is going to be, what is this? The two B's plus, what is this? Plus the 2 HE. And then the breadth, how am I gonna deal with this? Okay, let me just write it like this. So I'm just going to say, okay, the volume is equals to what? Is equals to this 50 minus HE, guys. They say that In order for us to get 50, remember we have 40 minus 2h. In order for us to get to 50 minus h, it means from the 100, we are dividing by what? By 2. Yeah? From 100, we are dividing by what? By 2 there. So now we can say, okay, let's divide by 2. So to divide by 2, divide by 2, divide by 2, divide by 2, the 2 rationalize. So you have 50, which is equals to b plus what? Plus the h. So now b is what? Is 50 minus h. So now your length, I don't know which one you can call your length, guys, but I'm just going to say this is my length, 50, the length and the breadth, there's 50 minus h. And then I can call this my what? My breadth. So let me see, my breadth is going to, oh, okay, look at way. Oh, guys, remember, you have to look this inside this shape, not the out. This is why it was confusing me. You don't have to look at this one, the one that you are seeing outside there. You have to look the inside, you know? The inside. Because they say that a box is made from a rectangular piece of cardboard. This piece of cardboard, né? So you are making a box there. So this is the HE, the B, the B, the B, the B. So this is your breadth, height, the length, whatever you want to call it. So now the breadth is, I'm just going to say the breadth is this part there. The one that we calculated to be what? To be 40 minus 2H there. And the height is just the height. Understand? It's just the height. So just leave it like that. So to write this nice, so say therefore V is equals to what? Start with the HE, or by 50 minus HE into, what is this? 40 minus 2H there. Guys, I hope you understand what we're doing here. Let me repeat this again. Let me repeat this again. Remember, this 40 here, for us to find, okay, for us to find this length, for us to find this length here, you say what? Remember, we're dealing with this white, the white part there, that's where we're looking at. So you say the total length is 40 minus this part, the one that we cut, minus those two. This is 40, the total minus 2h when you sum them. It means now the height, the length of this part here is what? Is just this part is just 40 minus 2h there. And then to find this part here, it means you're going to say from 100. That's what I did there. From 100, you sum all of those. So to find this b, you're just going to say, take it this one to your left. So now b is what? B is simply 50 minus h. And then now this height, the height that is just what? The h. So now the volume says the volume of any shape is what? The length times the breadth times what? The height. The length is what? The length is 40 minus 2h. The breadth is what? Is 50 minus h. The height is what? Just the height. You see how it is? I'm sorry to confuse you in the first place, né? So I was looking at the other part there. So, but I hope you understand, né, guys? So now let's take a look at the next question. So they say that for which values of x or h, for which value of h will the volume of the box be a maximum? So now the volume is what? Is a function of what? Of h there. So you can write this as a function of h. So h. So you have h. What am I doing now? Let me erase this. So this is he into 20 minus he, and then 40 minus 2h. For us to take the derivative, guys, here, it means we have to multiply everything out, né? So now, let's keep the he first outside. Let's keep the h outside. So 20 times that, let me see. 40 times 20, that's like 800. This times that will give you negative 40h. This will give you negative 40h, and then plus what? Plus 2he squared. So now he is equals to, let's group, I'm going to start with this, and then this part will give you negative 80 he plus 800. So now this is going to give you 2he cubed minus 80 h squared plus 800 he. So remember, we have to let this be 0 when we take the first derivative. So the volume in terms of h is this. This is the function of the volume. So now let me divide here. So now our formula is v. H is what? Is 2 h cubed minus 80 h squared plus 800 h. I didn't miss anything there, guys. Let me see that and that. Okay, I think, yeah, it is correct. So now take the derivative of the volume with respect to what? To h. The derivative of this, I'm using the power rule, so this is 6h squared. Let me see, 80 times that is to be, I know it's 160, negative 160, né? So yeah, I don't have to use my calculator. 80 times 2 is negative 160 plus 800. And then, okay, let me write this nice 800. So you have to equate this to 0, you have 6h squared minus 160h plus 800. So now, to solve this, let's divide both sides by 6. So this rationalized there is this give you h squared minus, let's see, 160 divided by 6. It's not a nice answer. It's 160 divided by 6. That's like 80. I don't need that. So let me just keep it like this. From here, I can just use the quadratic equation. So h is equals to minus 160 plus or minus the square root of b squared minus 160 squared minus, minus 4 a is 6, c is 800, all over 2 a is 6. So h is what? I'm tired. Let me see. Plus the square root of what? Negative 160 squared minus 4 into 6, and then to 800 all over 2 into 6. So the answer that I got is 20. h1 is 20. So now let's take a look at the h2. So let me use negative now, replace with negative. So I have like 20 all over 3. So let's go back to the question. For which, remember, h is equals to 20. h1 is 20. h2 is what? Is 20 all over 3. Let's verify that. Okay, yes. So now, for the question was, for which values of h will the volume of the box be maximum? So let's draw our table there. So now let's try values less than 20, values greater than 20. To the first derivative formula, I have to take this side so that I can see what I have there. So now, guys, you're just going to say, okay, this is your first derivative. This is your first derivative, né? So you say what? You say 6 into, let's try negative, okay, less than 20, that's like 19. And then that's square the minus 160. And then you'll have 19, okay, not square the plus 800. So the answer is negative, né? And then let's try greater than 20, 22. 22. This one is going to give you a minimum. 20 is going to give you a minimum. Once you have a negative, 0 and then positive, your function decrease and then what? Increase. So let's try 20 of, let me see what's 20 over 3. 20 over 3 is 6.67, guys. So let's try 6, né? Since the 20 over 3 is 6.67, let's try 6. 6 is you see, the answer, this one is going to give us a positive, let's try 7. It's going to give you a maximum, guys. This one is going to give you a maximum. Because now, what you have, this one gave you for h is equals to 20. This one gave you a negative and then positive. So it means you have what? You have 0 here, and then this gives you what? A minimum. So now, let's try with, when we tried substituting h is equals to 20 all over 3, which is approximately 6.67. We know here at the maximum or stationary point that the gradient is 0. We substitute and then we have positive and then negative. So you see your function is increasing and then 0 there and then increase. It gives you what? A maximum. So therefore, h has to be what? Has to be 20 all over 3. And let's check the units, the centimeter. So h has to be 23 over or 20 over 3 centimeter. Yeah? For the volume to be a maximum. You can conclude, guys. Né? So now let's take a look at the next question. A rain gauge is in the shape of a cone. Water flows into the gauge. The height of the water is h centimeter. When the radius is r centimeter, the angle between the cone and the radius is what? Is 60 there, as shown in the diagram below. So now the first question says that we have to determine in terms of HA and leave our answer with a positive. Oh, leave your answer in sad form. Okay, that's not a problem. So now, guys, we have to determine what R in terms of H. Ne? R in terms of H. We are not given the volume here. Ne? We are not given the volume. So it means, what are we going to do? We're just going to say, if we have to take a look here, this is a right angle, the triangle. Ne? What you have inside the cone there is what? Is a right angle, the triangle. You can see it's forming a 90 degree there. So remember, whenever you have a 90 degree angle, you think of what? Of SOHCAHTOA. So SOHCA is what? SOHCA is sine, which is what? Opposite to the angle, and then adjacent to what? To the angle. So you're just going to use sine there. So sine of the angle, which is what? The 60 degree, is going to be what? You say opposite, which is what? The height all over what? The hypotenuse, not the hypotenuse, but the r, which is the adjacent. And then opposite, oh, it says opposite of adjacent. We're not going to use sine. Let's try with cos or car. So it says what? Adjacent over what? The hypotenuse. That's not gonna work. Let's try tan. Tan is what? Opposite, which is the angle or the side opposite to your angle, which is h, and the adjacent length there, which is what? The r. So we're just going to use what? The tan. So now I'm just going to say tan of what? Of 60 degree. This has to be what? The opposite, which is what? The hypotenuse. Not the hypotenuse, the h. The adjacent is what? The r. So now let me see, the tan of 60 is the square root of 3. Tan of 60 is square root of 3 is equals to h all over what? The r. So now from there, guys, we have to what? Determine r in terms of h. Okay, we have to leave r as in terms of h. So cross multiplication there, you'll have what? You'll have square root of 3 times r, which is equals to what? The h there. Divide both sides by square root of 3. Therefore, r in terms of h is h all over the root 3. This is your answer there. Okay, determine the derivative of the volume of the water with respect to h when h is equals to 9. You see now, we have to use what? The volume formula. So the volume formula, you have to see which one will be a correct one to use, guys. This one, or this one, this one, or this one. This one, guys, this is for sphere. This is the volume of what? Of a sphere, guys. You don't have a sphere here. This one, yes, you're going to use this one. Why this one? You're just going to say remember the volume is what? The volume of any shape is what? The area of a base, which is what? If you have to look, your base is what? Is a cycle. The area of a cycle is what? Is pi r squared. And you have to multiply by what? By h. But now you have to also divide by 3. Yeah? So therefore, the volume will be what? 1 all over 3 and then pi r squared times what? The h. So this is the formula that you'll use. So now v is equals to 1 all over 3 pi r squared times the h. So now they told us that h is equals to what? Is equals to 9 there. So the volume, they say the volume of h with respect to h. This means that h is the volume is the function of what? Of h there. So now this is 1 all over 3 pi. Your r is what? Is h all over the root of 3 and then squared, and then let me first keep this. I will make the substitution, guys, don't worry. Ne? So now let's see when we multiply this inside. I'm just going to say, okay, let me not use the calculator there because I can see that what you have there, this will be h squared, and then if you have something like this, the 2 and the 2 ratio, it is the 2 and the square root rationalize, so your answer there is 3 times what? The h there. We can like multiply the h there, so now it will give us what? uh h cubed now. So here you'll have h cubed times this. So now you'll have something like pi h cubed all over 3 times 3, that's like 9. This is the volume in terms of the volume is a function of h. So what is h? H is 9, né? So determine the derivative of the volume of water with respect to h when h is equals to 9. So now let's take the derivative of this. The first derivative here with respect to h. So okay, let me just write it nice for you. This is the same as what? As pi all over 9. Pi all over 9 is a number, but now we're differentiating with respect to h, meaning h is your independent variable there. So the derivative of the volume with respect to what? To h is going to be what? Use the power rule. This exponent multiply with it the base. So you'll have 3 pi all over 9 from the same exponent reduced by 1. Erase this, so you'll have h squared. So now let me see 3. Okay, this is 1 all over 3 3 3 6 9 1 2 3. So this is 3 and 2 h and then squared. Don't forget the pi. So make the substitution now, né? So dv all over dh, or dv with respect to h there will be pi all over 3. What is h now? H is 9 squared. What is the answer there? So guys, I'm using my calculator here so that I don't waste time, né? So 3. I'm so sure that you have your calculator there with you, né? Because you know we are busy with calculations here, so you have to have a calculator with you. So now they say determine the derivative of the volume of water with respect to h when h is equals to that. So you take the first derivative, so this is the same as v prime of h, guys. This is another notation for the derivative. So answer is 27 pi. So now let's take a look at this one. Let's say a perfectly cylindrically closed cola has a capacity of 340 ml. The capacity, guys, that's the volume. The volume is what? That's the capacity. The volume is the capacity. Is the total amount of what? Of tiny increment or tiny cubes inside what? Or that can be inserted inside a shape or an object. That's the volume. So like think of a volume, guys, as what I can say. You see water inside the bottle, that's what the volume. Water inside the bottle, that's the volume. Or air inside the room, that's what the volume. So the volume is what you're given here, that is 340, and then millimeter to centimeter. So you have that. Find an expression for the height of the can in terms of h. We know that the volume is what? The volume of any shape is the area of the base multiplied by what? By the height. What is the area of the base? When you check there, this is like a Coca-Cola is cylindrical, guys. It's cylindrical and they say it is closed there. So the volume of any shape is the area of the base, which is the cycle here. So the area of a cycle is pi r squared, and then you say what? Multiply by height. So now the volume is 340, which is equals to pi r squared times h. To express h, you simply divide both sides by pi r squared, pi r squared. this rationalized dot. Therefore, h is what? 340 all over pi r squared. So now, hence or otherwise, there's a connection, guys. Show that the total surface area is that. So surface area, guys, remember, you say what? You have they say that it is closed, meaning you have to include the top part, né? So you have the cycle at the top and then the bottom. So the area of those is what? Is pi r squared. And how many are they? There are two, né? So plus what? Plus the layer. The layer is what? The circumference. And you can see it's in the shape of what? Of a cycle. And the circumference of a cycle is what? Is 2 pi r. And don't forget about the h when you take it from the bottom to what? To the top. So multiply by what? By h there. So now the surface area is going to be 2 pi r squared plus 2 pi r. The h is what? Is 3 into 40 all over pi r squared. So now you'll have what? You'll have 2 pi r squared. 2 times, okay, 6 times 2, 3 times 2, that's like 6. So you have 6, and then 2 times 4, that's like 8. The 2 times 0, that's like 0, and then pi. Okay, let me remove this. So the pi rationalized, the r and 1 r here rationalized. So you simply have what? R. Is this the same as this, guys? Voila, it is. So now this is what am I doing? So now I can say now surface area is a function of what? Of r. So now this is your answer there, guys. The next question is guys, here we're dealing with cost. Remember, optimization is all about what? It's all about reducing the cost while increasing what? Efficiency. That's optimization, guys. We don't want to use a lot of material to make something. We want to make sure that we use little as possible. So now they say that the cost of metal sheeting is what? Is this. You see, the cost to make this metal sheeting. Metal is something that consists of elements. Oh, let me not go to that. Let's put a full stop there. So now the cost of a metal sheeting is this. Now for the talking, guys, let's come back here. So now let me highlight this. I can highlight here because so what I wanted to do there. So now what's happening with this? Okay. So now our surface area, guys, is what? Is in centimeter squared. So now let's turn this into what? Into that centimeter there. So how do we do it? We are just going to say, okay, the cost per, or let me start by saying this. 1 meter, guys, is the same as 100 centimeter. Not one milliliter. 1 meter is the same as what? Is 100 centimeter. So since you have meter squared there, it means now 1 meter squared will be what? 10,000 centimeter squared. You'll be like, man, how did you find that? Square this 100, say 100 into 2. You'll have this number, 10,000. So 1 meter is the same as what? As you have to know your conversion, guys. This is pure maths. Know your conversion. So now, from there, I'm just going to say, okay, the cost now has to be what? In centimeters. So the cost per centimeter squared is what? I'm just going to say 8 all over what? All over 1,000. 10,000, not 1,000. So now let's see what's the answer there. So you have to divide by that, guys, so that you converted it into what? Into centimeter. To have the cost function, we want to find what now? The cost function. To find the cost function, remember I told you that this is the total cost, which is equal to what? The cost per what? Per centimeter cubed multiplied by what? Multiplied by the surface area. The surface area is in terms of r, so you can say surface area to that. So the cost is what? Is 8.008 multiplied by the surface area is what? Is 2 pi r squared, and then plus what, 680 all over what, all over r. So now this is what the cost function. Now this is the cost function. You'll use this formula to deal with the question, that the next questions. So now let's take a look at the next question. Remember guys, this is 2 and this is 3. This is 2 and this is 3.1. Let me see, 3.1. So now, is this 3.1? Find the next, yeah, 3.1. So now 3.2, we are here now. Find the value of the radius which minimizes the cost. So now you have to take the derivative of what? Of your cost function. Yeah? So now the cost function is what? The cost function is r is equals to, guys, don't forget, I will show you that thing. I'll show you. Don't forget. So now where it come from, ne? It's just a convention, guys. But here's an advice, guys. Just know that 1 meter is equals to what? 100 centimeter. And if you're dealing with meter squared, just square everything. You understand? When you square everything, now you have what? Centimeter squared. So that's the convention. But still, why are we dividing? Now I'll show you. Okay. So now you have to divide what? Not to divide, you have to take the derivative. Remember, they say the value of radius which minimizes what? The cost. Remember, when always, guys, when it comes to optimization, when you hear something like these words, minimizing, maximizing, least, increasing, decreasing, you just take the first derivative. Now, you take the first derivative here. So now, when you take the derivative, remember you keep this and then take the derivative with respect to what? To r of what? Of the inside function. So now you have to equate this to 0, remember? So you keep the 0.0008. The derivative of the inside will give you what? 4 pi r. And remember, I should have took the reciprocal of this. Let me erase here so that I can take the derivative there. Nice, guys, using the basic derivatives rule. So remember, this is what? 680 r minus 1. So when you take the derivative of this, you'll have negative 680 and then r minus 2. Yeah? You always subtract by 1, reduce by 1. So we divide both sides by 0.008, 0.0008. This rationalize this. You'll have 0 into, now we can take this back. So you'll have 4 pi r minus 6 into r squared. Take this to your left, you'll have 680 r squared is equals to 4 pi r, divide both cross multiplication there. You'll have what? You'll have 4 pi r cubed is equals to 680. This 680 seems to appear so much, ne? 8 divided by 4 pi. We've been seeing this 680, ne? Seems like optimization. It's real life problem, guys. This is real life problem, ne? Each and every company, guys, want to use as least as material possible, ne? They don't want to use much. So now this rationalize, you left that. Let's see the cube, the root of that thing there. The cubed of what? Of 680 all over 4 and then pi. 3.78. I saw this 3.78 somewhere. 3.78. We're busy with those things there up, ne? Remember, it says minimize, and I've already proved that, guys. Remember, this answer R will always be a positive value, 3.78. And then that has to be centimeter, ne? Don't just cram, guys. Know what you're doing, ne? So now let's see the next question. Determine the minimum cost of 1 can. The minimum cost. Find the value of the results which, okay, determine the minimum cost of 1 can. Guys, this is easy. You just take this value, plug it to your what? To your original function. Not your first derivative, but your original function. So now this is 4. My original function is what? See, let me first write down the function, the cost function, guys. Yo, I'm tired. Yo, guys, have you seen what time is it? Check the time, guys. Have you seen what time is it? Yo, I think like, what time is it? Close to 3 a.m. in the morning. So I have something like this, 680 all over R. That's why my brain is not braining well, but it is now. Okay, now make the substitution. That's 3.78. Is it in it? No? Yes. So we have something like this, 2 pi 3.78 squared plus 680 all over 3.78. Let's see what the answer it is. Hey, I'll use my calculator now. Okay, 0.0008 multiplied by 2 into pi multiplied by the answer squared. Not ancestors, guys. Answer squared. Ne? I didn't say ancestors. Multiplied by answer squared. Hey. So this is what I have. 0.2. Let me just write it to 2 decimal places. 0.22. Ne? So 0.22. So, and then this is what the thing in there. So now let me make sure that I give you the conclusion. Determine the minimum cost of one can. Therefore, okay, let me say when it is misbehaving. What's wrong? When, okay, let me say when R is equals to 3.78, the minimum cost of one can is 0.22, and then this is just to be rent. Okay, this is cost, guys. This is rent, né? Guys, do I have to show you that? Just divide, guys. Né? Just divide. Just divide, guys. So from meter, just from there to there, guys, just divide, guys. No, you just have to divide it there. Do the math. I need the answer in the comment section. I need the answer in the comment section. But I will show you guys this conversion, what. It's just that now I still have to think. You see, if I waste time there showing you, and then when it comes to these things now, my brain will no longer be that, what is this, active. A bit tired. So now sketch, okay, the sketch below graphs of f of x. Okay, f of x is a parabola that is there's a front face, so you have negative x squared plus 10. So it means that at this point you have a positive 10. And then that, let's say g of x is equals to negative 1. It's just a straight line there. So what is this? HJK is a rectangle enclosed by a parabola and a straight line. B is the point of intersection of what? Where's B? B is the point of intersection of where? KL with the x-axis. All right. So they say that if BO is x unit, okay, it's x unit, calculate the length of GK. Where's GK? GK is just from here to here. These things from year to year. If O to B is x, also from where is this? JK. Okay, I would say also from O to J would be x. So therefore, J to K is what? That's number 1. So JK is just 2x. You just sum this 2. So x will give you 2x. So therefore, they need also the length of what? Of JK there. Where's JK? JK. Okay, JK is between this part, and we know from the origin to K, that's -5. So, and we also know that this X value here, remember guys, to find the corresponding Y value here, you will say what? If this is X, the corresponding Y value will be what? F of X. You just what evaluated that value there. So it means now let's evaluate at that value of X. So to evaluate that value of X, we'll have -x² plus 10. So it's just the original function. Now, you're just evaluating at the value of X there. This value of X, guys, if it was -2, I'll have to substitute -2 and see what is Y that side. Understand? So that I can see the distance from there to there and then add it with that. So now the distance from O to K there, it is -5. So it means I have to what? Remember distance, guys. When you are dealing with distance, you don't like care about the negative, né? So now let's add it there. So when we add the 5, it means now therefore f, I can say, yeah, let's add it to the function here. The function is y, so that distance is what lk. So let me say lk is going to give you what? The -x² plus 15. So that's the distance, guys. That's what they say in terms of what? Of x. Everything is in terms of x there. So now the next question, show that the area of a rectangle, that part there, is given by this. Wow. So remember, you need what? You need the length. You need what? You can call this your height, whatever you want to call it. So now, this is number 2. So the area of a rectangle is length times, you can say the height. So the length is what? This part there. From there, from J to K, it is this part. It is what? It is -x² plus 15. And then I have to multiply with what? With the height. The height is what? Is 2x. So multiply by 2x there. This 2x, JK. So now, this times that will give me -2x cubed plus 80x. This is your answer, same as that one. So now calculate the maximum possible area of a rectangle. Calculate the maximum possible area of a rectangle. Okay, remember, whenever you hear about maximum, or whenever you hear maximum, take the first derivative. So now your function is a function of what? Area is a function of x, meaning x is your independent variable. So take the first derivative. This is -6x² plus 80, and then you equate to what? To 0. You don't just equate to 0, you have to know why. At the stationary point, the gradient is what? Is 0. That's what I want you to speak. This is the language, guys. Now, that's the language. So it's equals to 30 all over 6 all over 6. And then x² is equals to 30 all over 6. Take the square root. So plus or minus, x is equals to plus or minus. So as this, the square root of 30 all over 6, square root of 5, né? So square root of 5. So this makes sense. Hey, what's happening? You see, in a sad form, a sad, guys, is something like square root of a, square root of b. That's a sad form. Yeah. So it makes sense that our answer is in a sad form. Hey, let me erase this. So for the maximum, guys, I have to verify here. So we draw our table there. So we have to try those values, né? So let's start with x is equals to the square root of what? Of 5. So we substitute a value that is less than this 5. Let me see. Square root of 5 is 2.3. 2.3. So if it is 2.3, I have to substitute values less than I'll plug 2 and then plug 2 and then 3. So now let's see, I have to substitute the derivative formula. So let me plug 2 and then squared plus 8. This is giving me what? A positive, né? Then let me plug 3. Has to be negative. So this means that it is positive here and negative. So this is a maximum there. So x is equals to 5 is what is a maximum. So therefore, x is simply what the square root of 5. And this has to be units. Since they didn't give us any units there. So square root of 5 units. Calculate the maximum possible area. The max, not the value of x, the maximum possible area. So it means now you have to take what this answer and plug it to what to your original function. So first you have to confirm if which one is a maximum, which one will give you a maximum. Ne? So now take this and plug it to your original function then. So your original function is that one, negative 2 into root 5 cubed plus 30 square root of 3. Yeah, square root of 5. Where did I get the 30 from? Guys, this is 5. I hope you guys can see it. Hey, 5. This is 5. So this is what? Negative 2 square root of 5. That's cubed. It's like plus 30. Yo, the answer is something else. 20.07. So 20.07. This is your answer, guys. So calculate the maximum area of a rectangle HUN. So they said leave your answer in insert form. Ne? They said in insert form. So let me just go back and write those insert form because they said insert form. Yeah, but it's something else. Let's say negative square root of 5 plus positive 30 to that. So this is, let me erase this. This is negative what was that? What was that? 20 square root of what? I think I saw 5 there. Plus 80. I think I saw 10 there. Let me see. Even 2. This is, what's happening now? Yo, what's happening now to my things there? As you see, this is misbehaving. Okay. Want to destroy our lesson. So now, guys, this was negative. What's that? 10. Let me just punch it here. So tired, guys. Let me just use my calculator here. And the answer that I got here is different from what I got there. So this is 20 square root of 5. Let me make sure let me see what I did then. You see, I placed 2 there. You see, that's why I'm saying I'm tired, guys. You see, the answer is this. So maybe God was telling me, no, forget. That's not the answer. I would have said this is the answer. So now this is the answer list. So calculate the maximum possible area of a rectangle and leave your answer in insert form. So you say that this is what the maximum area possible and this is in insert form, and you are done like that. Sure. Yo. Someone will have panic in the exam. So, yo, what is this now? What is this now? Is this still our scope? Are we out of scope? The scope is beyond. Eh? This thing is misbehaving. Eh? Okay. Miss Devon. Devon wants to cut 2 cycles out of a rectangular piece of cardboard of 2-meter long. But guys, whatever you're seeing here, it is written. Let me see about this one. Let me see this one. The radius of a largest. Okay, yeah, this was makes sense. The radius of a larger cycle is half the width of the cardboard. Okay, where's the width of the cardboard? Let me something here. A rectangular piece of cardboard of 2 meters long. Okay, 2 meters long and 4x meters wide. So this is the width, né? So it means now the what? The radius of a larger circle is half the width. Half the width, let's divide by 2. So it means the larger circle is what is 2x. Excuse. So now they say the smaller circle has a radius that is 2 all over 3 the radius of the bigger circle. So what they mean is just you say 2 over 3 multiply by what? By 2x. And this is going to give you what? 4x all over 3. So now that's the radius of what? Of a smaller cycle. So 4x all over 3 there. So now they say that we have to show that the area of a shaded region is given by that. There is a lot that we have to do here. So let's see what are we going to like approach this. Show that the shaded area. Okay, they want this, not those ones. So what we can do, what if we find the total area of the rectangle? The total area, okay, we're given this formulas. The total area of a rectangle, guys, is going to be what? If I use the, let me see, show that the total area of a rectangle is given by that. I cannot use the perimeter, because if I use the perimeter now, I'm talking about what? But yeah, I can start there, né? But if I also use this circumference, now where is this taking me? Yeah, well, okay, let me stick with the areas. This is the area of a circle, and this is the area of a what? A rectangle. And then this is what? A cycle, guys. So let's start with a rectangle. This is the length times the breadth. The length is what? Is 2 meters. 2 meters. So that's like 2, and then times 8x. So this is going to give me 8 times 8x. Even. Now I'm just giving the answer because I already work it in my mind. And so this is 4x, guys. The length, guys, this is the longest side, which is 2. What is the breadth? There's 4x. So the answer is what? So that's that. So now was 2 forward. So this is 8x. That's the area of what? Of a rectangle. So now let's find the area of a cycle. We have 2 cycles there. We have the bigger cycle, the smaller cycle. So I'm just going to say this is in okay, let me start with the bigger cycle. The area of a bigger cycle is going to be what? Pi r squared. So now pi, hey, I cannot use those things there anymore. Okay. So now the r squared is what? Is 2x and then squared. So now the answer that this thing is misbehaving now. Why is it freezing? So now it's pi into 4 and then x squared. So this is your the area of a bigger circle. Now the area of a smaller circle is going to be what? You'll say pi and then r squared. The pi and then r squared is what? Is 4x all over 3 and then squared. So the answer there will be what? Is 4 into 4 squared is like okay, 4x squared is like 16x squared and then 9 into that. So now I have to sum those two to get what? The total area, né? So now it means now the total area, or the total let me just say area, and there's to be a function of x for these two there. So for cycle, né? So it's going to be what? I have let me start with the bigger cycle. So let me just say 4 pi x squared plus this one. So that's going to give me like 16 pi x squared all over 9. Let me see, 16 divided by 9. That's like 16 over 9. So it's just like that. So now Remember, this is the area of a rectangle. So we're just going to say here the area. Now the total is let me erase this. This thing is misbehaving. Né? The area now, guys, is going to be what? The total, which is 8x minus those two. So the 4, let me just say minus 4 pi x squared plus, or this has to be also has to, okay, let me just keep it like this, plus 16 pi x squared all over 9. You see, you have 9 there, you have 52. I will show you how they got it. Ish. This is misbehaving. Né? So now this is into that the 8x minus, so for us to have the common denominator, guys, I have to multiply the 4 by 9. So let me see, 4 times 9, that's like 36. So I have like 36 pi x squared and then plus 16 x squared. You are not seeing that. You're not seeing there, né? What I was writing there. So therefore, now the area of the what? Oh, we have the 8x. So let's see, 36 and then 16. This is going to give you 12 into that 4 and then 52. So, and then you left what? The negative 52x. Oh, I left the pi. This thing is misbehaving. Yo. Come on. Are we going to finish here? Ay. Are we gonna finish? Hey, see what I've done now. I think I will have to cut it here now. Because what the hell is that? So guys, this is your answer here. This thing is misbehaving. I think I'll have to cut my lesson here. Because I don't want to waste this lesson. Imagine if I have to start back. So now they say determine the value of x such that the area shaded is region. As you see, when they say maximum, take the first derivative. So now this is, I'm just going to copy that since it's just the same as what we have there. So the first derivative, so this is good. Let me see, 52 all over 9 times 2. This is 104 all over 9 and then pi x equal to 0, 8 minus 104 pi all over 9 x. Take this to your left, you'll have 104 pi all over 9 x is equals to 8. You have to divide both sides by this, so therefore x is the same as what? The same as saying 8 multiplied by 9 all over 104 pi. So x, let me see, so 8 divided by 104 over 9, so pi. So I have something like x is equals to 0.22. Yeah, 0.22, guys. So this is the same as 8 multiplied by 9 all over 104 pi. So it's still the same thing. So this has to be meters, né? So now that's it there. So now calculate the total surface, calculate the total area of a cycle. Of a cycles. Oh, cycles. The total area of a cycle. Remember, this is the area of a cycles that we got here. This one, not this one. This, before subtracting, this is what we got here. So I'm just going to say, this thing is misbehaving, yo. I can't copy my things now. Okay, fine. Let me just write it here. Guys, I think I have to cut this lesson, because I don't want to waste this video. Imagine recording for like 2 hours for nothing. 16 pi. This is the area of the cycles, guys. So now let's see what the question is asking us. Calculate the total area of a cycle if the area of a shaded region is to be maximized. So remember, the area of a shaded region is x is equals to what? We got x to be 0.2. So simply take this value and plug it there. Understand? So you simply say x 0.22. So 4 pi into 0.22 squared plus 16. Let me take this to the side. Then pi into 0.22 squared all over 9. So let me see what I have there. So this is 4 into pi multiplied by 0.22 squared, and then plus 16 pi 0.22 and then squared. I think I have to cut this lesson here, guys. So 0.88 is my answer. So therefore A 0.22. So that's your answer here, guys. Yeah. So now let's see. Calculate the total area of a circle if the okay, now the total area, you can say total area is simply what? I think it's because I've been like recording for a while now. I've been recording for a while now. So that's why this thing is misbehaving. Yeah? I've never used this before. So guys, let me see how many questions we are left with to oh, just two questions. I can complete this, ne? I can complete this. Let me just be fast and then. Okay, the number of not cyclones. The number of molecules of a certain drug in the bloodstream T hours after it has been taken is represented by this equation. Okay. Determine the number of molecules of a drug in the bloodstream 3 hours after the drug was taken. Remember, this equation shows what? The drug after what? After it has been taken. So now this is we have to determine those number of cyclone 3 hours after the drug was taken. So you simply say what? M at 3 is equals to negative 3 cubed plus 3 into 3 squared plus 72 and then what 3. So let me see. Negative 3 cubed plus 3 into 3 squared and then plus 72 3. So my answer is 216. This is what I got there, guys. Yeah, this is what I got. So this is 216. And now this is determine the rate. Guys, whenever you hear about rate name or whenever you see these words rate, just like the first derivative. Understand? So the rate at which the number of molecules of the drug stream is. So now they're giving what? The T. So let's take the first derivative then. So the first derivative, look at what we have there. So the first derivative, I'm using the power rule, negative 3 t squared plus 6 t plus 72. So now place 2 there. So this is negative into 2 squared plus 6 and then 2 plus 2. 8 plus 72. Let me see what's the answer there. Negative 3 into 2 squared plus 6 into 2 plus 72. So the answer is just 72. So determine the rate at which the number of molecules. So this is 72. There. Number of molecules in the blood. Okay, exactly 2 hours after the drug. This is 72. So now, how many hours after taking the drug will the rate at which the total number of molecules of the drug bloodstream is changing be maximum? Be maximum. So what you have to do there, this is our first derivative. So let me just write it again. This thing's misbehaving, misbehaving now. So now this is my first derivative. So now I have to solve for t, guys. So they're saying how many hours. So we are solving for what? For t there. So equate this to 0 since you see maximum. So at the stationary point, you know the gradient is 0 there. So you can use the quadratic formula. I'm just going to use quadratic formula. Negative 6 plus minus the square root of b squared minus 4a c all over 2, and then a is what? Is negative 3. So let's see, square root of a negative 6 plus the square root of 6 squared minus 4 minus 3 into 72. all over 2 into negative 3. I have negative 4, and when I replace with positive there, so now when I replace with negative, I have 6. So now we have to like prove, ne guys? So we know this is 0. It has to be 0 at the stationary. Look, what time is it? 3 or 12 past 3, guys. I'm tired. Yo. So now, guys, I have to plug it there to our first derivative formula. So negative 3, I have to plug less than, let's try less than 4, that's negative 3. And this is 2 plus 6, negative 3 plus 72. The answer is positive. Let's try greater than 4 is like, oh, this is greater than negative 4. Let's try less than 4. Less than 4 is negative 5. So negative 5 is negative. That one was positive, isn't it, guys? This is negative. Let's see. This is positive and then negative. So it means now you have negative, positive. Let's give you what? A minimum. So therefore, the answer will not be this. And I'm so sure, I'm 100% sure the answer is equals to 6. So x is equals to 6. So they say how many hours? So like 6 hours. Yeah. Therefore, 6 hours. So now this is the last question. This one. You see, guys, this is the same. Hey, where's those things? This is the same. Look, this is 20 what? This is 2016, November 2016. You see what we have here? This is the same question. It's just that they change the story now. You see, this is 2015, 2015, 16. So check. You're talking about the mass of the babe. If you can check here, the the restriction or the interval. Let's go there. You still have the interval there. You see, you have what the interval. Ish, this thing is misbehaving. Eh? It's misbehaving. You see, you have the interval, and then you're given a function. So now the difference is just now this is different story. They're saying that now we're dealing with the mass of a baby in the first 30 days né, of life is given by this. Okay. T is the what? The time in days, M is the mass. So write down the mass of the baby at birth. Guys, you know that at birth, yeah, this is what T is equals to 0. At birth, we are starting at 0. This is 0. Because now there's a mass of the baby in the first 30 days. So the first day we started what 0. It has to be 0 and then 1, 2 up until 3. So that we have to write when the reason why they said write down is something that which is given. When you place 0 there, everywhere there is T. Now the mass is what 3000. So the mass is simply what 3000 at T is equals to 0. Ne? At what time T? So when the baby was born. So now a baby's mass usually decreases in the first few days after birth. Yeah? After birth. On which day will the baby mass return to its birth mass? This is the birth mass. Remember, guys, at time t is equals to 0, this is what the birth mass. We haven't counted. That's the birth mass there. So now they say on which day will the baby's mass return to its return to its birth mass. So just going to say the mass at t has to be equal to what? To 3000. You have to equate those two equations for it to return to what? To its birth. This is the birth, guys. Birth math. So now your function is what? Is t3 minus 9t squared plus what? 3000 is equal to what? 3000. And then you know this and this rationalize when you take it to that side. So now you have what? 0 into t3 minus what? 9t squared. So now we can rationalize. Let's see if I take what is this? if I say 3 into let's see, this won't work. I wanted to do something, but it won't work. So now I'm just going to what is this? Take the common factor there. So left t squared the minus 9, which is t. I still okay. Let me just take t squared. So t squared will be what? This will be t just t, and then what? Minus 9 is equals to 0. So this will give us t no matter what. So now t is equals to 9. So we have t is equals to 0 and t is equals to 9. Remember, at t is equals to 0, this is what? The birth mass. Ne? So now they say a baby's mass usually decrease in the first few days. After what? After birth. After birth. On which day will the baby's mass return to its birth mass? Return to its birth mass, this has to be what? T is equals to 9 then. Understand? So you replace if you replace 9 to this equation here, or what is this? Let me confirm. Let's confirm. So let's see. If we say 9 cubed minus 9 into 9 squared, and then plus what? Plus 300. This is what? This is 3000. You see, even if you place 0, you still get what? 3000. So now we can say that since they're looking for let's say what? Let me read the question. A baby's mass usually decrease in the first few days. First few days. So this is till now. Yeah, first few days after birth. This is after birth. So therefore, t is equals to what? 9. So 9 days after 9 days. So you can see that after 9 days. On which day will the baby's mass return to its best? So after 9 days. Then. Oof. Now this is the last question, guys. I'm tired, and I still have to show you the conversion, guys. Guys, just divide by that number. And just know the conversion from this to that. You see, just divide by that. So now they say that on which day will this baby have a minimum mass? A minimum mass. It means now you have to what? You take the first derivative, ne? Let me show you. Our original function is what? M into t. Let's take the first derivative there. So we have what? 3 t squared the minus 90. The derivative of that is just 0 there. So now equate to 0. Since you know that the stationary point, the gradient is what? Is 0 there. So now let's take the common factor, or let's factor 3t out. You'll have t, and then you'll have negative 3, like that. So these times this will give you 9. So it means 3t is equals to 0. T is equals to 0. This is the, remember guys, this is the what? The mass birth, ne? This is what? The birth mass. At t is equals to 0, this is the birth mass. So now t is equals to 3. So on which day will the baby have a minimum mass? That's to what? Be day 3. So we can say on day 3. Because at day 0, guys, this is what? The mass, or this is the birth mass. So now they say, on which day will this baby have a minimum mass? So on day 3, you'll have what? A minimum mass. So now, guys, the last question. On which day will the baby's mass be decreasing the fastest? The fastest. Okay, fine. So now let's take this. Okay, this is our first derivative, no? So remember, this is 10.10 now and 10.4 now. So the first derivative is what? is 3t squared minus 9t. On which day will the baby's milk be decreasing the fastest? So now we can take the second derivative. This is going to give us what is this, 6t minus 9, and then equate this to 0. 6t minus 9, take this to that, ct both side by 6. So therefore t is what? So let me see, 9 divided by 6, that's like 3 over 2. 3 all over 2 there. So 3 over 2 is like approximately what? 1.5. This 1.5, guys, this is the point of inflection. So remember, you're dealing with a cubic function. Let's see the value of a if it is positive. Okay, the value of a is positive, so it means you have a function that's started by increasing and then decrease and then what? Increase. So now this 3 all over 2 is the what? The point of inflection. That's going to show us where is the function decreasing, increasing most or not increasing. So from here to here, that's concave down. So let me use another color there. This thing is misbehaving. Yo, yeah. So now you have something like this then. Hey, what's happening now? Yo, now I don't know, guys, what happened there.